This is AP Calculus AB Worksheet 1-2, limits to a point of a function. The directions for the first side is to plug in to evaluate. I'm noticing that the directions for the backside says that each of the following will have the indeterminate form, so you will factor, cancel, and then plug in. But again, you should typically try to plug in first to see if it even works. So if I'm plugging 5 into this x and this x, that's going to be giving me a 5 plus 3 over 5 squared minus 15. It's going to be 8 over 25 minus 15, which is going to be equal to 8 over 10, which reduces, dividing top and bottom by 2, is going to be 4 over 5. All right, and number 2, again, plugging in a half. So this is going to be 3 times 1/2 quantity squared, and that's all going to be multiplied, and I'll just keep the parentheses, actually. That's all going to be multiplied by 2x, which is 2 times a half, minus 1. All right, so simplifying a little bit, this is going to be 3 times 1 squared over 2 squared times 2 times a half is 1. And this is going to be 3 times a fourth times 0. And anything times 0 is 0, so the final answer here is just 0. Number 3, plugging in 1. This is going to be 1 cubed. I guess I have to be careful about my parentheses here. So it's going to be 1 cubed plus 3 times 1 squared minus 2 times 1 minus 17. And 1 cubed is just 1. So be careful with this one. Remember, you don't multiply first. You take a power first. So 1 squared is 1, and then 1 times 3 is 3. So this is 3 minus 2 minus 17. All right, so I'm going to do the positives there, the negatives over there, minus 19. And 4 minus 19 is a negative 15. So I'm going to get negative 15 for my final answer. All right, moving on to number 4. Plug in negative 4. Okay, so I'm going to have negative 4 plus 5 to the power of 17, which is going to be 1 to the power of 17, which is just 1. In number 5, plugging in the 2. And there's actually 2 ways to do this one, because I think this top is factorable as you do x plus 3, x plus 2. You could cancel out the x plus 2 and just plug in x plus 3. I could do 2 into here. That would be 5. I'm going to do it just plug in like a brute force attack, though. I'm going to say this is 2 squared plus 5 times 2 plus 6 in the numerator. The denominator is going to be 2 plus 2. Oh, that's not a 2. 2 plus 2. That's going to be 4 plus 10 plus 6 in the numerator, 4 in the denominator. Don't do this. Don't cross cancel. These are being added. If they're being multiplied, you could do that. This is going to be 20 in the top, 4 in the bottom. 20 divided by 4 is 5, which is exactly what we got doing the factoring. This one is going to be difficult for most students, I imagine. So powers of 2/3 are a review of Algebra 2. But if I plug in, I'm going to do it up here, negative 2 minus 6 to the power of 2/3 is really the same thing as negative 8 to the power of, yes, it's to the 2/3, but it's to the power of 1/3 to the power of 2. I'm going to break apart my fraction, keep the 2 right there, keep the 3 in here. Anything to the power of 1/3 is the same thing as a cube root. So this is really the cube root of negative 8. And then that's still quantity squared. I don't really need quantity squared. I can just put squared right now. And the cube root of a positive 8 is 2. So the cube root of a negative 8 is negative 2. So I can say this is negative 2 squared. And you might ask, Mr. Sindel, you're not allowed to take square roots of negatives. And I agree with you. You are, however, allowed to take cube roots of negative. Whenever this index here is an odd number, negatives inside is fine. Whenever this is an even number, like 2, a square root, or 4, a fourth root, you cannot have a negative in there unless you want to go into the imaginary realm of complex numbers. And negative 2 squared is a positive 4. And that's our final answer. And I should make a note also, you cannot have imaginary numbers on the AP Calculus test. They don't do anything with imaginary numbers. All right, number 7. Plug in a negative 2, and that's pretty straightforward. Negative 2 plus 3 is underneath that square root, and that's going to be the square root of 1, and that's just 1. Number 8, review of our trigonometry. Let's see what we have. This is going to be e to the power of 0 times cosine of 0. All right, well, cosine of 0, we need to figure out what that evaluates to. And to do that, I'm going to remind us that 0 lives right here. I could say pi over 2 lives there, pi lives there, 3 pi over 2 lives there. You could say pi over 4 lives there. You need to know all of your basic angles for, it's going to be usually radians on AP Calculus. They very rarely will do degrees. I don't know if I've ever seen degrees happen. So 0's there. Cosine is asking for the x-coordinate, aka what is this length right there? That was not the best. There we go. What is that length right there? And the answer is because it lies on a unit circle, the radius of a unit circle is 1, that distance is 1. So I can say that is 1. And anything to the power of 0, aside from 0 for the base, but e to the power of 0 is definitely also 1. And 1 times 1 is 1. So our final answer here is 1. All right, number 9. Ooh, some more trigonometry. Plugging in, I get the natural log of sine of pi over 2. I added my own parentheses right here for my inside. So where is pi over 2? Again, let's go to that unit circle. So if I come over here, pi over 2 lives right here. That's pi over 2. So the sine is asking for the y-coordinate, aka what is this distance right here? And because it's a unit circle, again, that distance is 1. So this sine of pi over 2 goes to 1. And the new problem is, what is the natural log of 1? Natural log of 1 is one of the two things you have to have memorized. Natural log of 1 is just 0. As a note here, so I'll put this as a note, little asterisk, note, natural log of e is 1. That's the other number that you have to have memorized. Natural log of e, no, it's 1. Natural log of 1, no, it's 0. Those are the two things you have to know for evaluating natural logs. Number 10, some more trigonometry. All right, plugging in. Here we go. We have e to the power of cosine of, not x, but pi, cosine of pi. And cosine of pi, again, let's go ahead and do our unit circle. Pi lives right here. That's pi. It's a 180-degree rotation, but we're in radians, so it's a pi rotation. And cosine is asking for the x-coordinate, so what is this distance right here? And that distance is a negative 1, because we went left 1. So I'm going to say cosine of pi is evaluated at negative 1. So this turns into e to the power of negative 1. You could box that, and that's fine, but maybe on a multiple choice test, that's not there. Maybe they'll say it's something else. Maybe they'll say something like 1 over e to the power of positive 1, which we just say 1 over e, and that's the same thing. Either of those could show up. You're going to be taking multiple choice tests for the first 6 units, I think, so be prepared for either one of these two answers. Again, negative power means flip, and then keep the same power. 1 went away because 1s go away. Number 11. Oh, we got a lot of things to do here. Okay, so we have piecewise form. So this is saying the limit of f of x as x approaches 3 from the left. And this is the left piece because anything less than 3 is to the left of 3. So I could label these up here. This is the left piece and this is the right piece. So if I'm plugging into the left piece, that means 3 is being plugged into this x. And I can say this is going to be 3 squared minus 5, which is 9 minus 5, which is 4. All right, now we're saying the limit of f of x as x approaches 3 from the right side. So I'm plugging this 3 into the right piece, this x right here, and I can say this is just 3 plus 2, which is 5. All right, and then 3 from both sides, I'm analyzing, were these two numbers the same? If they are, you just relist it down here, but they are not the same, so this is a does not exist. And finally, f of 3, this is the height at 3. Like, okay, just plug in 3. Where is it equal to 3? Well, this is where it's greater than 3. This is where it's less than 3. And where it's equal to 3. So because of that little bar right there, it is equal to 3 on this piece. So I'm going to plug into that piece again. And hey, we already did that. The answer was 4. I can come down here and just say it's 4. All right. My typical strategy of when I box numbers and when I don't, if there's work, I box a number. If there's no work, you assume that's the answer. All right. That was everything. There's no like E. Yeah, okay. Number 12. We have this piecewise function. And again, I'm going to take the limit of g of x as x approaches 1 from the left. And the left piece is always first. Again, this is the left piece. This is the right piece. So I'm plugging in 1 into this piece right here, and I'm going to say that's 3 times 1 minus 5. That's 3 minus 5, which is negative 2. Go ahead and box my work. And now I'm taking the limit of g of x as x approaches 1 from the right side, so I'm plugging 1 into this x, and this is going to be negative 3 times 1 plus 1, which is negative 3 plus 1, which is negative 2. Hey! The same answer, which means the double-sided limit down here is going to be negative 2. It's either going to be wherever they match or D and E. Those are the only two options. And then finally, this one, G of 1, where is it equal to 1? It's equal to 1 on that left piece, so whatever the left piece was, negative 2, you just copy that down here, and you get negative 2. Excellent. And no E, we are on to the back side. Okay, so the front side was just plugging in, right? The front side was plugging in. The back side is, now we're going to have an indeterminate form. Each will have an indeterminate form. I'm going to quickly go over that just to get some logic. So if I have 3 squared, that's going to be 9. 9 minus 3 is 6, so I'm left with 6. And negative 2 times 3 is 6. So the top is 0, bottom is clearly 0. You do indeed get the indeterminate form. If you don't know what that is, it's 0 divided by 0 or something like that. And you need to do something else. And that something else in this case is factor, cancel, plug in. So factoring the numerator gives us x, let's see, minus 3 and x plus 1. Mr. Sindel, how did you do that so fast in your head? In AP Calculus, I assume you know how to do factoring because you learn it in Algebra 1, review it in Algebra 2, review it in Pre-Calculus, and then you're here. So you've already seen it 3 times, hopefully, if not 4. And the way I do it, I'm going to do it once here and then never again in this video. I do ninja stars. That's how I teach it. Sometimes people call them diamond problems, but I say, okay, what do they add up to? What do they multiply to? They multiply to the last number. So I'm going to put a negative 3 over here. What do they add to? This middle coefficient, negative 2, without the x, just negative 2. And then you ask yourself, what two numbers first multiply to negative 3? 3 is a prime number, so the answers have to be 1 and 3. We have to figure out if we are going to have negatives, though. Those numbers do exist there. They might be both negative. One of them might be negative. They also have to add up to negative 2. So if that 3 is a negative 3, let's check. These two multiply to negative 3. These two also add up to negative 2. So those are the values that I plugged in, negative 3 and 1. It doesn't matter the order. I could have done this one first. It doesn't matter. All right, so there's my mini factoring lesson. That's my scaffolding for you guys. X minus 3 is still the denominator. Notice I have done step 1. I have done my factoring. Check. Now I'm on to cancel. So to cancel, those two are going to be canceled, right? So I think I'm going to do that in blue. Those two cancel. And then I'm on to step number 3. Plug in again. Plug in was like step 0 to show the indeterminate form, right? We're plugging in again, and we're going to plug in 3 into this x. 3 plus 1 is 4. So this is going to be 4. All right. Number 14, again, factor the denominator. I'm going to rewrite the numerator real quick. This is going to be x minus 6. And by the way, I'm doing something kind of illegal. I should mention it right now. If I have the limit here, I should be rewriting the limit here. If I were taking a college level class and they were super nitpicky, they would take off points because I'm not rewriting the limit. Technically, the limit of this thing is not just equal to this thing. The limit goes on and on and on until you get a final number. So it feels a little bit weird for me to not write the limit, but I'm going fast. I'm just going to say, okay, it's that stuff right here. I'm going to ignore the limit. I know I'm taking the limit in my head. So it's going to be x, what multiplies to 12 and multiplies to negative 12 and adds to negative 4. That's going to be negative 6 and 2. So and x plus 2. So I factored, I canceled, and then I'm going to plug in again. So here you have to be careful. Just because you cancel things out doesn't mean it's not a fraction. It's still a fraction. In fact, I'll do a whole extra step here. What we have right now is 1 over x plus 2. And then we will be plugging in the 6 into the x. And that's going to give us 1 over 8. A lot of students might make the mistake of thinking the answer is just 8 because that went away and you just plug in there. It still has to stay a fraction. All right. And number 15, we're plugging in negative 7. Again, I can see that clearly goes to 0. Let's go ahead and do our factoring, canceling, and plugging in. X plus 7 stays on the top. Okay, so how do you factor this thing? Again, you can still do the ninja star. It'll still work, but I recognize that's a square, that's a minus sign. I have two squares, and they're taking the difference. The difference of two squares factors as a conjugate pair. This is x plus 7 and x minus 7. Again, conjugate just means you change the sign on the inside. It's a pair because there's two of them. Conjugate pair, done. All right, factoring done, canceling done, and plugging in the negative 7 yet again. I'm going to have negative 7 minus 7, which is a negative 14, and that stays in the bottom. I have a negative 14 in the bottom. What's left in the top is a 1. Whenever you cross things out when you're doing your factoring, or doing your canceling, sorry, whenever you cancel out, you leave the 1. So I have this giant fraction that's a little bit too big, but negative 1 over 14. And again, you remember this, but this is the same answer as negative 1 over 14. And this is the same answer as negative out front, 1 over 14. All three of these are equivalent to each other. It doesn't matter where you put the negative as long as you have only one of them. If I had a negative 1 over negative 14, that would be incorrect. All right, we're moving on to number 16. So this one is going to factor a little bit weirdly. I'm going to do the thing that most students do, even though I know I don't have to do it. You can see that you can factor out a 2. If I factor out a 2, and I can factor out, okay, between x to the power of 6 and x to the power of 3, x to the power of 3 is the low-hanging fruit. That's the small one. It's x to the power of 3. And then what's left over is I'm essentially dividing each of these by a 2x cubed. Divide each of these by 2x cubed. What's left over, and you can see, okay, 2 divided by 2, it's no coefficient, right? X to the power of 6 divided by x to the power of 3 is just x to the power of 3. And then I have this 6 divided by 2, which is 3. So this is, I'm going to keep that sign here, the plus. So plus 3, and then I have x to the power of 3 divided by x to the power of 3. Those are gone. I'm just going to cross cancel them, and I'm left with 2x cubed times x cubed plus 3. In the denominator, I'm going to go a little bit faster now. There is no coefficient that I can factor out between 4 and 3 because they are co-prime. So I can only factor out an x to the power of 3, again, because it's the lower of the powers. And when I factor out x to the power of 3, I'm left with a 4x to the power of 2 plus 3, just like that, plus 3. All right, I have done my factoring. Now I need to do my canceling. When I do my canceling, this x cubed and this x cubed can be crossed off. You cannot cross off this 3 and this 3 because there's a plus sign. You can only cross off things that are being multiplied. This entire x cube is being multiplied. This entire x cube is being multiplied, technically like that, right? That's why I was allowed to cross it off. Be careful when you're canceling. And then from here, I'm going to plug in. That's the last step, right? I'm plugging in a 0 into that x right here and to this x right here. So my new problem becomes, I still have that 2, and then I have 0 plus 3, and then down here I have a 0 plus 3, and that's going to turn into, okay, so 2 times 3 is 6. The bottom is going to be 3, and 6 divided by 3 is 2. There we go. Last two problems. Here we go. When I'm plugging in 0, yep, I get 0 over 0. Let's go ahead and factor out the greatest common factor. In this case, it's going to be x squared. When I factor out the x squared, I'm left with 5x to the power of 2 plus 8. And in the denominator, I'm going to factor out an x squared, and I'm going to be left with a 3x squared minus 16. So I did my factoring, doing my canceling, x squared clearly goes away, and then I'm going to plug in. What number am I plugging in? 0 is being plugged into this x, 0 is being plugged into this x, and that's going to cancel out that entire term. That entire term is going to go to 0. Let me just say that's going to go to 0. This one's going to go to 0. And be careful here. A lot of students will make the mistake of saying, Mr. Sindel, that's 8 over 16. That is incorrect because you have to take the sign in front of it. It is a positive 8 over a negative 16. So there's the correct answer. And if I reduce that by dividing the numerator and denominator by 8, you get 1/2 that is negative. Let's leave the negative down there. Perfect. All right, the last question, number 18. Again, plugging in 0, yep, indeterminate form. Let's factor out the greatest common factor. In this case, the greatest common factor is just x in the numerator. And in the denominator, you don't have to do it, but I'm going to be silly, and I'm going to factor out an x. And there we go. I factor out the x for the denominator. When I factor out the x for the numerator, I'm left with a 3x. And don't make the mistake of ending it here. You have to do 3x plus 1. Just in case you're wondering why we have to do the plus 1. If x is the greatest common factor, you divide each of these by x. Divide by x, divide by x. Clearly, that x squared and x turn into an x. This x divided by x turn into the 1. You still have to have the 1. All right, so from here, we can cancel. X's are gone. And then I can plug in, yet again, plugging in 0 into this x up here. This is going to be 3 times 0, which is 0, leaving behind the 1. And I want to change the red, though. In the denominator, I have the 5, and the answer is just 1/5. I believe that concludes worksheet 1-2. There's the back side if you want to see. There's the front side if you want to see. And thanks for watching, guys.